So propositions. So logic is the science of the correctness or incorrectness of reasoning, or the study of the evaluation of arguments. So probably the best known application mathematical logic is in the area of higher mathematics and in the field of computer science, where the software development makes use of logic circuit design. So propositional logic is a declarative sentence subject for affirmation or denial. This is yes or no, and for affirmation it's true, and for denial it's false. So you identify if a sentence is a propositional logic if it's a declarative sentence that answers if it's true or false. So for example, I am beautiful. So this is a proposition because there can only be a true or false for this statement, an answer for this. It there's no trolls. It cannot be both. It's only true or false. So another example, rhombuses rhombus rhombuses are squares. This is a proposition because it is either true or false. So i- are rhombuses squares? A rhombus is look looks like this, and the square is straight, equal sides. So rhombuses are squares. Rhombuses are squares. This is a proposition and the truth value is false. So for the next one, we have welcome to Iligan City. So is this a propositional logic or a proposition or not? Welcome to Iligan City. So this is not a proposition since it is not a declarative statement, declarative sentence subject for affirmation or denial. You cannot choose between true or false for this sentence. So, last example, we have my seatmate will get a perfect score in the logic exam. So, my seatmate will get a perfect score in the logic exam. So, this is a proposition. My seatmate Sentences like this is a proposition. Will get a perfect score in the exam. This is a proposition, but the truth value for this will only be determined after the exam. You can say that it is true or it is false after the exam. So this is a proposition. And the truth value is still undetermined. It will only be determined after the exam. Position. I hope you have answered the exercises for this part, so you have the mastery on in determining if a statement is a proposition or not. So we proceed to the two different types of proposition, the simple proposition and the declarative proposition. So when we say simple proposition, it is a declarative statement. Declarative statement that cannot be broken down any further into other component composition. From the word simple, it is a simple declarative statement. Cannot be cannot be broken down to other component propositions. Meanwhile, the compound proposition is formed by combining two or more simple categorical propositions by some logical connectors. So this compound proposition is a combination of two or more propositions. So how do you identify if a sentence is a compound proposition? It's easy because compound propositions use logical connectors such as not, and, or, if, then, and many more. Okay? So in simple proposition, you think only of one thought. Simple propositions are sentences having one thought. Simple propositions are called atomic propositions because they are building blocks of propositional logic. So a compound proposition is a combination of two or more categorical propositions by some logical connectors. So it can be a combination of simple propositions, and to identify if it's a compound proposition, it's easy because compound proposition uses not, or, and, if, then, and other logical connectors. So from the previous example, we have rhombuses are squares. So that is a simple proposition. So for this second example, we have, what if we say that it is not the case that square root of 5 is a rational number? The word not is a logical connector. Hence, it is a compound proposition. So now, if the sky is cloudy, then it will rain. So, can you identify which are the logical connectors for this sentence? It is the word if and then. Okay, so if you have if the sky is cloudy, then it will rain. So the word if and then are logical connectors. So this belongs to the compound proposition. Now let's proceed to the symbols and connectives of propositions. So we will be required to establish the truthfulness or falsity of a compound statement. In order to facilitate the process of establishing its truthfulness or falsity, propositions need to be symbolized together with the connective to be used. So the first symbol is this. The connectives for this is and, but, yet, while, etc. So in symbols, we have P and Q. So P and Q are sentences or declarative sentences. In other words, these are P and Q are propositions. So for example, I am a teacher for P and I teach math. So the first sentence, I am a teacher, is a proposition followed by Q, I teach math, and connected by the symbol and. The next symbol is the opposite, which means its connective is or. It can be written as P or Q. The next one is this, an arrow. Its connective is implies. P implies Q. It can be then. And see your module for other connectives. So the most common ones are implies and then. We can have P implies Q and or P then Q. In sentences, we've used the propositions as examples. We have if I am a teacher, then I am a government worker. If I am a public school teacher, then I am a government worker. Okay, this is the usage. So the next example is this. Two arrows in two directions. So this is the if and only if. This is commonly known as the if and only if connectives. So we have P if and only if Q. For example, I will go to Siargao if and only if it is not rainy. Examples like that. So this symbol is a negation. The connective for this is not. Or it is not true. So negation P. So if P is the statement I am a teacher, then this one is I am not a teacher, or it is not true that I am a teacher. So please do remember this. This is very useful, especially the symbols. We will be using this a lot in the next lessons in your grade 12 and in college. So please do take notes.